Hello everybody, I am Lynnyk, and today's topic is about DDos stack analytics. This is my second presentation of it. I would like to say a few words about implementation details. I decided to use Python instead of C# because it's pretty easier to implement math methods than C#, and it's kind of easier to visualize it with Matplotlib. What is the scheme? I use Python with pandas. Pandas is used for data storage. It has a data frame, and I will use NumPy for cleaning the data. I didn't do it right now. But it will be implemented till the end of the course. And then we need sklearn to train our model. Also we use Seaborn and Matplotlib to visualize our results. Solution is to create a desktop app that will give you current information about DDoS attacks in the world and predictions for the near future by selecting attributes that you are interested in, for instance period, time step, flow ID, and so on. How does it simply works? Firstly, we need to collect the data. I collected it from Canadian Institute of Cybersecurity. Then we need to clean the data to get proper results in the future. We have to divide data. Why do we split data? Because we have to get test model results and train model results. Then we need to analyze our results of method we decided to use and teach a model. So first we need to collect the data and check its attributes. So as you can see, my data set contains right now 10,000 rows. It's because I decided to cut most of them. My PC cannot load it properly, so it's loading too long. But I'll improve my results till the end of the course. Then we need to give the to list all the attributes, like flow ID, source IP, timestamp, total length of BUD packets, VUD packet length max, mean, and so on. Then we check the zeros at our data set. As we see, mostly attributes that contains the data has no zeros, so it's okay. Then we describe our data set, for instance like count, mean, and so on. What syntax did I use? I used, as I mentioned it before, Python syntax with a few frameworks, like for instance pandas. Firstly, we see that we have to read our data. Read it with pandas data frame read CSV. Then we describe it with rows in dataset, columns in dataset, if it contains nulls, and so on. Then we pick few attributes that are really useful for us. At the end of the course, it will be possible to pick your own attributes that you are interested in for user. Okay, so we divided our dataset and we printed. So when you have to visualize few attributes to check if it has any feature work. Firstly, we see total length of UUD packets. As we see, it has about 3,500 and 4,000, and also it has lower ones like 800 and so on. It's a bar chart. I used to visualize it. So the second figure is total VVD packets, and the third one is total backward packets. As I mentioned, we use it to find out if the data is actually workable. Bar diagram. This is bar diagram of one of the attributes, like total length compared to time used to send this packets. As you can see, it has three local maximums, so the model result will be different dependent on how we divide data with this attribute. And we have confusion matrix showing not confusion matrix, I'm really sorry, it's scatter plot. It's math diagram showing two attributes at different points. Data of different attributes at different points. Code of it, as you can see, I used matplotlib to visualize it, and I picked a few attributes to make it. Problem formulation. First of all, before training model, we have to split the data, as I mentioned before, like xtrain, xtest, ytrain, and ytest. We use sklearn to try and test split model, and we pick a test size 0 for 45. As I mentioned, dependent of how it will split our model, the results will be different because of local maximums on the previous diagram. Then we need to scale our data, but we don't scale actually it for linear regression, it's for future SVM and decision tree diagrams. Then we create a logistic regression model, and we fit it with our trained data, and then we predict our data. We check if our model attributes, our model attributes like model classes, model intercept, and so on. I used linear regression. It's the first method I decided to show you. When do we use linear regression? Linear regression regression analysis is one of the most important fields in statistics and machine learning. There are many regression methods available. Linear regression is one of them. What is regression? Regression searches for relationships among variables. For example, you can observe several employees of some company and try to understand how their salaries depend on the features such as experience, level of education, role, city they work in, and so on. So it's really useful for our application to show dependency between different attributes like total length, time, and backward packets sent at that time. So yes, we check our model attributes if they are correct for us, like model classes, coefficients of the given model, and so on. Then we need to evaluate our model. We use it with model score, and we predict it. We predict proba with test data, and we predict actual data with train data. We predict our model with actual train data. Test the only probability of one. It's the test proba, and the test the probability of either 0 or 1 is output is actually our train data. So we get model train score and model test score. Why do we have 008 model score but not like 074 or something like that? It's because I decided to cut my data set, because it's pretty hard to load it every time when debugging, but in the end it will be okay. Then we built a confusion matrix. Confusion matrix I'm sorry, this is lagging. Confusion matrix is a table that is often used to describe the performance of a classification model or classifier on a set of test data for which the true values are known. The confusion matrix itself is relatively simple to understand, but the related terminology can be confusing. For instance, we use it to find out if it is possible or not possible. Is the simplest confusion matrix that you can meet. And our data set, it is shown that it contains like 500 to 500 columns to rows. Then we had to make classification report about accuracy, weighted average and macro average. And we can improve our model with setting C in the linear regression to high. Previous ones was set to 2, and now I decided to set it to 10. So it really improves our results because cycling it more times. Thank you for your attention. And the literature I used you can check out in my presentation. Now I would like to move to actual code. Okay, I'm sorry, I'll fix it. Firstly, we need to output our data description, our data description. As we can see, we get, as I mentioned, 10,000 rows in data set and 87 attributes, and we check the zeros in our data set. Then we describe it, and we print columns in our data set, flow ID, source IP, and so on. Next step is to pick our attributes that we will use, like flow duration, total VUD packets, total required packets, total length of VUD packets, total length of VUD packets. Why did I decide to use exactly that attributes? Because they show how during the flow duration and what time does it need to send those packages, and the length of the packages. Next was to print it, but we don't need it now because it was shown in the previous presentation. Then we need to build our diagrams. It was mentioned earlier. I'm really sorry. Okay. Next step I forgot. I'm sorry. How do we do it? We plot it with matplotlib, and we pick attributes that we want to describe. Next thing we have to do is to split our data. We split it with xtrain xtest. We use x, that is data frame that was created based on actual data frame. I was picking that attributes, and here is created by Cosinit, and we used the size almost 0.45 because we don't want to load all the data from this data set every time. And we use random state 0 because we don't want to switch every time places in the data set. We want to get clear information about it. Next thing is to scale our data, but as I mentioned, I will use it for another methods, but I decided to include it to show it. Why do we need it? We need it to get better results, for instance for decision tree or for SVM, to get better diagrams at the end and the better model. Then we need to build a logistic regression because it's my main topic today, and we fit our model. Then we get a prediction of our model for Y. We can print our model, and we want to print model classes. We want to print also model intercept and coefficients of this model. So let's run it. Okay, I'm sorry, it's still loading too long. Okay, it is by the way, it is loading too long because for our data set we had to set a really high iter because of it contains too many rows and data. Okay, we get logistic regression info, like I mentioned random state that we decided to print, and so on. We see max iter. Okay, then we get model classes description, we get model intercept, and we get our accuracy and macro AVG. This is the accuracy that we will see by improving model, but the previous results we get 0.08 accuracy. But when we set this to 10 instead of, for instance, 2, we get really better results, like 10% or 20. Okay. Second thing I want to show you is evaluation of our data set. We print the probability of 1. It's the proper prediction in escalator, and we print the real possibility of either 0 or 1 as output. that is our main prediction, is that my analysis will be based on. Okay, now we see this. It is an NumPy array that will use and clean it. Like to test the probability of either 0 or 1 as output. As you can see, this is the real one we'll use, this is the proba. Okay, when we have set this, we have to print our model train score and print our model test score. And as we can see, we have 008, and for test score it is 007. And we have confusion matrix. That is the endpoint, and this one I have shown it already to improve our results. So I'm sorry, 1 minute. Okay, and it's our confusion matrix. By now that's all I had to show you. Thank you for your attention. Hope to see you later. Thank you. Goodbye.